Hello everyone, my name is Sebastian, and I'm one of the founders of Paima Studios, and we're one of the leading companies building fully decentralized games as well as autonomous worlds. And in this video, I'm going to talk about forkable games. That's to say, games that can be modified permissionlessly. That means you can add new game rules, and those game rules don't necessarily have to be developed by the company who created the game, but by anybody in the community. Now, why are these important as a concept? There's a few reasons we'll get into later, but the key thing is that right now, a lot of people are trying to build these kinds of fully decentralized games right now, be it to try and avoid some of the regulatory or security issues related to building Web 2.5 games that have a centralized server component, or be it to tap more natively into composability with other DeFi applications or different dApps on the blockchain ecosystem and try and appeal more to crypto native users. And so people are really interested in this kind of concept of decentralized games, and a lot of times these are called autonomous worlds. That is to say, worlds that somehow evolve over time independent of any kind of game studio that created it. And you can kind of see this in the definition of autonomous worlds given up by different people. So different people have different definitions, but usually it revolves some concept of evolving over time, as well as having no privileged centralized actor that's in charge of the game world. Now, the reason why forkable games are important is because if you look at these two things, they're kind of competing goals, right? How can you have a world that evolves over time if there's no centralized actor that's deciding how these games evolve, right? So you can see how these are competing goals. And the only real way to solve this is to say, okay, well, we'll have a world that can evolve, but there's no one person who's solely responsible for evolving the game world. They might be the main game studio, but theoretically, any other company could come in and propose updates to the game world and build on top of the game world. And so achieving this basically requires these forkable games where anybody can propose game updates to the game code, and the community at the end of the day, the players at the end of the day, get to decide which game rules are the best for them. So you might be wondering, well, are updates even required? So, perhaps having worlds evolve is a bad idea, and the world should be static. And just like we do with DeFi, once you deploy a dApp, that's it. There's no update. And in practice, this is not really how things have gone. If you look at a lot of the most successful autonomous worlds, for example, Pirate Nations does updates all the time. For Torochi, we've had 46 updates since their launch, and for other successful games like Primordium, they have launches all the time. And the key thing is that not only do successful autonomous worlds empirically have a lot of updates, as you can see from some of these graphs, like the updates actually bring in new users, improve user retention, and so actually having frequent updates improves your chance of having a successful game. Therefore, people obviously want to have more updates and evolve their game world over time. But how can they achieve this without introducing points of centralization that kind of goes against the entire point of what they're building in the first place? So to understand why this is a bit difficult as a dilemma is because of the way assets work in these kinds of decentralized games. That is to say, if you have gold in the game or wood in the game or any kind of resource, these are often represented as ERC20 tokens, that is to say, fungible tokens. And for ERC20 tokens, the main problem ends up being this kind of mint function right here, which is how do you define, how can you create new assets in the game, right? And if teams can create new ways to mint new gold, then somebody could create a version of the game that just mints infinite gold, and that would destroy the game economy, right? And so the control over this mint function ends up being the hardest part. And so this is why this is the main function, the main problem with decentralizing these games. You might be wondering, well, maybe I can modify the game function in a way that just doesn't change the mint function. Maybe we can build a game where people can add new features to the game as long as we just never touch some core accepted mint rules. And in practice, it's a bit hard because of the fact that everything's kind of connected, right? So of course, you have these first order problems, which is like, for example, you have an ERC20 gold token, and somebody from the community says, okay, well, let's increase the amount of gold you get from quests. This is not possible because you can't modify the mint function of the gold contract. Therefore, how could you get quests to increase the amount of gold without changing the mint contract to change the amount of gold that gets emitted, right? So these are first order problems, and so these ones are clearly not going to work. But we also have second order problems, which is, for example, somebody from the community says we should increase the number of wild monsters that spawn in the wilderness. But more wild monsters means more encounters, which means more inflation. But more inflation means more gold. But we can't modify the mint function, therefore we can't change anything that would lead to more gold in the world. And so you can see how even if you try to avoid touching the gold contract directly, even just the fact you can't update this ends up with a cascade of other implications on what parts of the game you can evolve and which ones you can't. So some of the ways you could try and tackle this, for example, is to say, okay, well, we'll just have a new ERC20 token every new version of the game. So version 1 is gold V1, gold V2, gold V3, gold V4. And this is kind of problematic for two reasons. The first one is, of course, it's a nightmare for decentralized exchanges as well as centralized exchanges, right? If you have to go around to everybody and say, oh, there's a new version of the game, everybody, you got to update to monitor this new contract instead. This is just a miserable experience for everybody around, especially because some of these games have updates fairly frequently, sometimes once every week, once every 2 weeks, and sometimes even faster. And so trying to convince everybody, especially centralized exchanges, to update these contracts so often is just a non-starter, right? It's not going to happen. The second one is, well, if you have a gold V2, gold V3, gold V4, how do people update from the old gold to the new gold, right? How do people bring their assets from the old version of the game to the new version? And one way you could do this is with the burn function, right? You burn your gold V1 to earn gold V2. But this actually hurts the ability to create competing forks, because it means that if you choose to update to gold V2, you cannot update to any competing forks, right? So maybe somebody proposes a V2, says, this is my proposal for the V2 of the game, introduces this new feature. But a different company says, I have a different proposal for a different gold V2 contract, and I think the game should go in this direction. If you have to burn your gold, it means you have to essentially pick one of the two game rules to be like the rules you follow, which makes it harder to experiment, because you're most likely to take the version of the gold upgrade you think is most likely to be a commercial success, not necessarily the one you think has the best game rules, which again kind of defeats the entire purpose of wanting to have autonomous worlds that can evolve based off player decisions and having the players be empowered to pick which version of the game is the most fun to them. So solution number 2, which is what we've been working at Paima Studios, is to just not have a single mint function, right? Instead of having a single mint function, you instead have many different mint functions. And in fact, there's a standard that does exactly this, which is called ERC1155. And not only does this standard help solve this issue, it's also supported by MetaMask, it's supported by OpenSea, as well as quite a few tools, including explorers and so on. So how does ERC1155 work in practice? So you can see here that ERC20 tokens, the way they work in practice, let me just get my mouse cursor. The way ERC20 works in practice, you have a mapping from your address to how much coins you have, right? So this address has 20 coins, somebody else has 30, somebody else has 10. ERC721 is non-fungible tokens, NFTs, right? So ERC721 is kind of like the inverse mapping, right? You have a mapping from an asset to who owns it, right? And there's only one owner of every asset. So ERC1155 kind of combines some concepts from both of these standards, which is to say you have different namespaces, and different namespaces have different ownership properties. So it's kind of like adding namespaces to the ERC20s. So the way this is typically used is, for example, if you want to have all the items in your game use the same contract. So you have swords, and within the sword namespace, you have different, ERC20 token like token ownership, and then within the shields namespace, you have different, addresses owning different numbers of shields. And so ERC1155 essentially brings namespaces into ERC20. So how can we leverage this to our advantage? The key idea is to have the namespaces in ERC1155 not be different items, but rather have the namespaces be different game rules, right? So if you have ID 0, that's the original game rules, and ID 1 is a different set of game rules, and ID 2 is a different set of game rules. And every time you make an update to the game, you essentially allocate a new ID and set that namespace for people's token balances in that set of game rules. And this is great because it means that you no longer need a permission for the mint function, right? You can say any new company, any new player that wants to introduce new game rules, they can just allocate a new namespace to themselves. And the key thing is that when you create a version of your game, you create a new game client for your players, you can define which IDs are valid for your game. So you can see, for example, in my new version of this game, I consider IDs 1, 7, 8, and 10 to be valid game rules, and I consider the other ones to be invalid. So it allows you to create game clients that don't leverage just one ERC20 token. They don't just leverage one gold, but rather they opt into all the golds you think have economic value, or have versions of gold that you think are compatible with your game's rules. So this allows you to essentially, bypass this mint function issue by allowing different people to define their own mint functions that encode these new sets of game rules for the game. Of course, this does introduce a certain UX issue, as you can see, for example, on OpenSea, right? So if you have different versions of the rules that have different gold, how would OpenSea be able to differentiate which rules are real and which rules are basically scams that nobody is playing, right? And so OpenSea, unfortunately, because they are not, really on top of autonomous worlds, are unlikely to ever support the standard, and so therefore we have to kind of provide to OpenSea the canonical set of game rules. So you as the creator of the game would say, okay, on OpenSea, here's my smart contract for my game. Here's the ERC1155. And by the way, consider ID 0 as like the canonical game rules. Therefore, when somebody goes to OpenSea, they can see the valid gold under game rule 0, but gold under different sets of game rules would be shown as invalid. And then later on, if you want to update the view on OpenSea, you go OpenSea and change which game IDs are considered valid. Now, the good news is that this is just a UI issue, right? If you have a different explorer that instead differentiates based off these game ideas, then you could get around this issue. Now, OpenSea might introduce this at some point in the future, but also we're working at Paima Studios to try and build a separate marketplace that kind of keeps this into account, so that for our games, as well as any other games leveraging this concept, you can properly have some NFT marketplace where you can differentiate based off the game rules which assets you want to buy. And in fact, we already partially have a solution for this, which is called our Torochi Gold Dex. That's currently right now on portal.paimastudios.com, which is a dex for the Torochi Gold inside Torochi, which is our autonomous world on-chain RPG game. So when you go to the dex, it will load up the gold that's only valid under the game rules that we at Paima Studios have considered to be the current canonical version of the game. But theoretically, the DEX contract and everything we've built is open source, so people can create their own wrapper for the different game rule IDs. And our goal is to try and make this DEX more flexible. Players can come in and define their own namespaces and trade on this DEX based on their own namespace that they think is valuable. And this empowers users and developers to create forks of the game, because they know if they create a fork for the game, that there's going to be marketplace support from day one, and that players who want to trade on their new version of the game rules can just go to the Paima Portal website, change the ID they want to look at, and start trading right away. So it helps a lot to solve the liquidity issue, and it helps a lot to enable forkability. It does introduce a new problem, which is that, of course, not only does OpenSea not really support this concept, but as you can imagine, Uniswap doesn't support this concept, as well as centralized exchanges don't support this concept. Like, for example, Uniswap does not even support ERC1155. It only supports ERC20. So this brings a new problem, which is that, this ERC1155 solution is great for improving decentralization, but makes it harder to get your token have listed or have enough liquidity on some of these other problems. So let's talk a bit about the way we're planning to solve this at Paima Studios, which is, first let's see how a traditional fully on-chain game will work historically, which is that you have some play over here. The player is interacting with the game contract, and as they play the game, the actions they do in the game can affect some kind of upgradable ERC20 token. And then you have some game developer that has admin keys that can upgrade this ERC20 token anytime. And then with this ERC20 token, you can interact with centralized exchanges and Uniswap and all these other applications. So this is the way things typically work. What we're trying to build at Paima Studios is what we're tentatively calling Paima Aqueduct, which is this way to coordinate between all these different forks of the games. And so what does that look like in practice? Well, you have a user and they're interacting with your game contract. As they interact with the game world, they instead get an ERC1155 with an ID based off the version of the game world they're interacting with. And because this is on-chain, as just a permissionless ERC1155 contract, they can already start interacting with the Web3 ecosystem for any dApp that supports these ERC1155s as is, right? So OpenSea, as well as MetaMask, as well as the Torch Gold DEX we're building, as well as potentially other things we're building at Paima Studios as well. But if they don't want to use the ERC1155 and they really want an ERC20 for better liquidity and centralized exchange updates, they can choose which ERC20 they want to connect to based off the different dev teams that might exist. So for example, one dev team might be the team that originally started the project, but you might have a competing dev team that has a different vision for the game and introduce new updates. And once you get into the ERC20 system, then you can start getting composability with the different platforms, exchanges and so on, based off of that. So now it's up to the dev teams to get their different ERC20 wrapper for the games listed on these different platforms. So we just talked about the difficulty of building forkable games in relation to ERC20 tokens. And if you want to pause this video for a bit to reflect on that, feel free to do so. But now we're going to get into two other topics that we're also working on at Paima Studios to try and increase the forkability of games. Now, the second problem we're going to talk about is synchronization, which is how do you actually synchronize a game node, right? And this is really important for permissionless games because if you're telling the community, oh yeah, anybody can create a fork of the game, but syncing the historical game state takes weeks, nobody's going to do it, right? Nobody wants to pay an expensive RPC provider, and nobody wants to spend an entire week synchronizing an Ethereum node on their local machine. You can see how this gets problematic, for example, for Ethereum Layer 1, where syncing an archive node is terabytes potentially in storage that you need. But this is even a problem for newer chains that are kind of gaming chains, so to speak, because a lot of these gaming chains, for example, Xi, which is one of the more popular kind of gaming chains out there, is currently having over 10 million transactions per day, which means that if you want to encourage people from the community to create their own fork of the game and they have to run their own node for the game, now they're stuck having to download millions of transactions per day to keep their full node up to sync, just to sync the few transactions related to their game. So this is not a fundamental issue of blockchain. Rather, it's an issue with the EVM in general, how this works. And so there's other platforms out there that are more well-suited to synchronizing blockchain data in a way that's more efficient, that tries to solve the kind of noisy neighbor problem. And these are called data availability layers. So the key features of data availability layers is that you, instead of having to synchronize the full blockchain history when you create a light client, you can instead create a light client that specifies a specific app ID. You say, I only want to download data from that app ID. And the goal of these data availability layers is that they enable synchronizing just a subset of data with comparable security to a full node. And so DA layers that you might be familiar with are Celestia, but at Paima Studios, we also recently added support for Avail as a DA layer for Paima Engine. So anybody who creates games using Paima Engine can now tap into Avail for DA and store their game data on Avail to make downloading of the game state much cheaper and much faster, which helps teams create forks of games in practice. So this is still something we're actively working on in the sense that we have Avail support, but we're working currently to try and make the DA layer faster, to try and make it suitable for gaming. So keep an eye out for more updates on the DA layer side of Paima Engine. Now we're also making a lot of updates to try and tackle desyncing from the zero-knowledge cryptography side, which is, if you're not familiar, ZK is a novel I mean, it's not maybe not new at this point, but still real interesting technology to try and instead having all the game state stored on chain, rather you can have the game state processed elsewhere and then have a zero knowledge proof that the execution was done correctly posted on chain. And there's a really interesting technology for this called recursive snarks. And recursive snarks is this concept that allows you to take different proofs and combine them together to a single proof of constant size. So if you have a proof from A to B and a proof from B to C, it allows you to combine these two proofs together to a single proof from A to C. And the key thing about recursive snarks is that typically they are constant size. No matter how many proofs you aggregate together, it's still a constant size proof as a result. For example, in Mina protocol, which is the main recursive snark platform like ZK VMS live today, these proofs are about 20 kilobytes. And this is really great because it means you can have an entire game session, for example, an entire PvP battle between two players, all compressed down to a single transaction of 20 kilobytes that can prove exactly what happened within that match. And so to support faster syncing of game state, leveraging ZK for this kind of compression functionality, we've shipped the ZK layer for Paima and Mina protocol support earlier this year. And again, we have more updates coming into the ZK layer for Paima to try and make it easier to create ephemeral rollups or ways to kind of scale these rollups more to meet demand as your game grows in user count. Now, we've talked about, two issues, which is first one, which is how do you get liquidity and tokens to work with these games? The issue number two, which is how do we get the syncing of these games to actually be fast so people can actually realistically spin up new versions of these games? The last thing we've put a lot of effort into is documentation, which is that if we're serious about having different games propose different forks of the game, there has to be some way to know how these versions of the game are different. What has changed? What the smart contract looks like? What are the APIs are exposed? What are the features? Right? And so documentation ends up being really important for people to easily build on top of these games and build ecosystems on top of them. So for Paima, we've put a lot of effort into document generation. So for example, we built our own Solidity documentation generation tool. So when you create forks of games, you can run our tool and you get a new set of automatically generated Solidity documentation so people can see exactly how all the smart contracts for your game work. Also, games are not just about smart contracts. They're often about creating very specific REST endpoints that might get data that's not easily accessible just from the Solidity smart contract, right? It might aggregate data from different locations. And so Paima also has, I probably can't point that far, but over there, so you can see we have a documentation generation for the REST API for your game. So for example, for our game Trochi, we have different endpoints to get, the current open arena matches, get the different players that are participating in the championship, get this kind of information. And so it allows you to easily show people who want to build potentially on top of your game what endpoints exist out there that may be able to leverage. And Paima also comes with an event system. So people can actually create WebSockets monitoring to aggregate state of game events that actually supports multiple stacks. So if you're not familiar with Paima Engine, the way it works is that it's kind of like a aggregation layer on top of different chains and stacks. So Paima Engine allows you to create a game that leverages both Solidity and Solidity and ZK together into the same game experience and abstracts that away from you. And what that means in practice is that Paima allows you to create events that are triggered on the combination of state of two different chains. You can say, like, if a user owns a specific NFT on the EVM side, and they've accomplished some kind of goal on the ZK side, emit this kind of event. So you're allowed to create events on the aggregated state. And we have very soon, later this month, a release of our event log doc generation. And this is great because it allows people to build block explorers and these kinds of tools on top of these different forks of the game by seeing what kind of events get emitted from the game state and how they can build tools on top of that. So we have quite a lot of stuff going on at Paima Studios to try and make autonomous worlds and forkable games and evolvable games a reality. We are hiring, so if you're a Solidity developer, full stack engineer, or an artist, get in touch. As well as we have some information about our docs and us if you want to get in touch with me personally. My TG is also Sebastien GLLMT, which is the same as my Twitter, which you can find in the description below. So thanks for your time, and yeah, keep building cool games.